Hello YouTube, fellow math students and math teachers, DeVore here again, and we are going to be doing the task Cafeteria Conundrums. This is once again out of the Mathematics Vision Project Math 1 textbook. We're still in Module 1, but we are very closely approaching the end. Let's read what the directions say. Between serving and preparing delicious school lunches, our cafeteria manager, Elvira, is busy analyzing the business of running the cafeteria. We previously saw the symbols for some of these things she measured. Now she plans to use those same symbols from serving up symbols to help Elvira to consider the pressing questions of the lunchroom. This means that if you have not completed the table from serving up symbols, you should not be watching this video. You should be finishing up serving up symbols, because otherwise this task is going to be very difficult for you. We are going to write equations or inequalities to express some of the conditions that Elvira sees in the cafeteria. Alright, so here we have our first one. Each lunch can have no more than 4 side dishes. So we need to find the number of items that can be in a lunch, which we know as capital T. We also know that the number of side dishes in a lunch is represented by NS. Each lunch can have no more than 4 side dishes, which means that if it can have no more than 4 side dishes, it can have 4 side dishes, but it certainly can't have any more than that. So we represent that as less than or equal to 4. Okay. Then we have more boys eat school lunches than girls. Well, boys is represented by B. Girls is represented by G. If B is bigger, then B is greater than G. There can be no more than 7 food items in a lunch. We know that food items is represented by T. It could be no more than 7, which means that it can be less than 7, or it can be 7, but it certainly can't be any more than that. Let's look at this next one. This one obviously has a few more moving parts. In each lunch, there are 3 more side dishes than entrees and twice as many beverages as entrees. We're going to write a couple of short expressions here. In each lunch, there are 3 more dishes than entrees. Another way of saying that is that the number of side dishes in a lunch is equal to the number of entrees. There's 3 more side dishes than entrees. Okay. There are also twice as many beverages as entrees. Another way of saying that, the number of beverages is equal to 2 times the number of entrees. We know that now. We need to write an inequality in one variable that shows the total number of food items in a lunch cannot be more than 7. Well, let's take apart the total number of food items for a second. I think that we can all agree that if I'm counting up the total numbers of food items in a lunch, that's the same thing as counting up the number of entrees, plus the number of beverages, plus number of side dishes. And that number, when you add them all up, needs to be less than 7. It says that we want to do it in one variable. Well, we know how to talk about beverages in terms of entrees. We can also talk about sides in terms of entrees. We can plug in then what we know. Number of entrees stay the same, and instead of putting number of beverages, I'm going to put 2 times my number of entrees, because we know that already, plus my number of entrees, plus 3. And that is still less than or equal to 7. Alright, we can leave it here. I do want to go through the process of simplifying this down a little bit. When I start combining my like terms, I count, 1, 2, 3, 4 entrees, plus 3 is less than or equal to 7. I want to get the number of entrees by itself. I want to figure out how many entrees we can have under our current system. So we can have let's see, if we subtract 3 from both sides, we have 4 entrees less than or equal to 4. Divide both sides by 4, I get NE is less than or equal to 1. This tells us something. This says that the number of entrees in a lunch has to be less than or equal to 1. Thinking about it, we can't really have half an entree, really. That's weird. You either have an entree or you don't. So we can have no entrees in a lunch. But we can also have 1 entree in a lunch. Any more than that, and it goes over our guidelines. That's pretty darn cool. Here we have the cost of food in a lunch is the total cost of an entree plus the total cost of side dishes plus the total cost of the beverages. Write an inequality that shows the cost of the food in the lunch must be less than $1.50. There we go. It said it right there. That was pretty easy. To meet district guidelines, the total price of a lunch must be more than $2.25, but less than $3.50. Okay, we have the price of a lunch being PL. So our first one says that it must be greater than $2.25, but it must also, the price of a lunch must also be less than $3.50. We can write this on 2 lines, but there is a shorthand that we can do, and this is called a compound inequality. You may have seen these before. We say that $2.25 is our minimum here. Price of lunch is going to be somewhere bigger than that, but then it's also going to be smaller than $3.50. This is a fancy way of showing that the price of a lunch needs to be somewhere between $2.25 and $3.50. I would prefer if you wrote that last line instead of writing it in 2 lines. It's just, in my mind, a little bit easier to read, and it's also easier to see what numbers are between what numbers. All right. Elvira knows that the number of lines that she can open in the cafeteria depends on how many food servers she has in the cafeteria each day and how many workers are needed in each line. Write an inequality that shows this relationship. I know that the number of lines in the cafeteria we represent with L. This needs to be less than or equal to, now I need to figure out the number of servers and then servers per line. And in order for our units to cancel out correctly, we write it in this fashion. We have F, which represents the servers per cafeteria, divided by W, which is servers per line. So you've got all your servers, and then you just have it per line. And that will help you figure out how many lines you need. Food workers are paid $11.50 an hour. That's pretty darn good. Elvira can't spend more than $500 per day on employees. Write an inequality that relates the number of food workers to the amount spent each day on employees. Okay. We have H being the number of hours that the servers can work. Okay. And then we have $11.50 because they are paid $1.50. Okay, so that's the number of hours. We have the number of hours that someone works times their hourly wage. Now, that's the number of hours each food server works every day. And then we multiply that again, because that's just one food server. We need to multiply that times the number of food servers that are in the cafeteria already. This will get us the total amount that she's going to be spending each day. We know that needs to be less than $500. Elvira knows that the money she gets from selling lunches has to be greater than her costs. The first thing it wants us to do is to write an expression for the cost of employees for each day. So we're actually going to pull that from what we had up above, because we're not going to put it on the inequality. They get paid $11.50 per hour, and then times the number of hours worked by one person, times the total number of servers that are in the cafeteria every day. Okay. Write an expression for the cost of food each day. Well, the cost of food we've already established as being cost of the entrees plus cost of the sides plus cost of the beverages. Okay. Alright, now we need to write an expression that shows that the total cost that she spends on food and on employees must be less than the amount she brings in from selling lunches. Here's how we can put that together. We have part of it already. It had us do that for the other part. We've got $11.50 times H times F plus the cost, so that's the cost of the employees plus the cost of food. It needs to be less than the amount she brings in from selling lunches. Remember that the price of a lunch tells us how much each lunch costs, but how can the trick is we need to figure out how many lunches are sold every day. The way we can figure that out is we count up the number of students who bought lunch, because we are assuming for right now that each student only buys one lunch. And that's a pretty good assumption. I mean, there might be kids who buy more than one lunch, but it happens so infrequently in this case that I believe that we can just say that it's one lunch per student. It's also possible that they may be just counting how many students have gone through, whether or not someone goes through twice. I think that's fair to say. If you disagree with me, feel free to send me a message about it and we can discuss it more in detail in an email. Alright, that was Cafeteria Conundrums from the Mathematics Vision Project Math 1 textbook. As always, if you have any questions, please feel free to stop in during my office hours. You can always shoot me an email, shoot me a message, and I will be more than happy to help you out with any questions you might have on this problem. This once again been DeVore, and as always, please remember to be awesome and have a great day.